In the last video, we talked about categorical data and categorical data displays. In this video, we're going to talk about numerical data and good ways to display that data. So at the top here, I have a set of numbers that represent the number of black-eyed peas in a teaspoon. Why would somebody count that? I have no idea, but it's a good example of a variety of different numbers, right? So evidently somebody scooped up a teaspoon of black-eyed peas and counted them out a bunch of different times, and here are the numbers that they counted in each time. So it's hard to see patterns in this data, but if we put it into a data display, sometimes it's easier for us to see patterns. And so what this person has done is created what we call a dot plot. And here our dot plot, every dot represents one of these data points. So you can see here we have 116 in our data, and so there's one dot. We have 2 17s in our data, so we have 2 dots. And it helps you to see, like I can clearly see here, that there's not very many 16s in our data, right? And there's a lot of 18s, 19s, and 20s, but most of the data is 18. So those are the kinds of patterns that you can see when you create a data display, such as a dot plot. A different way to do to represent numerical data is through a histogram. Now, a histogram, you might say, hey, that looks like a lot like a bar graph, except that a histogram is not representing categorical data, it's representing numerical data, and it's representing a range. So each bar represents a range of data points. Sorry, I'll make my line straighter. So the first bar here represents 0 to 9, then 10 to 19. You'll notice that each bar is consistently the same width, bandwidth, or bin width is sometimes what we call it. So each bar represents a grouping of numbers. And then we count up. So here, what we have is the average January temperatures in selected U.S. cities in degrees Fahrenheit. And then we have the number of cities that had that degree. So looks like only one city had an average January temperature of between 0 and 9 degrees Fahrenheit. Many more, in fact, 6 cities had average January temperatures between 30 and 39 degrees. Now, we don't know the exact temperature. We can't say they all had 20 to 32 degree temperatures. No, we don't know that. But we know it was somewhere in that group of 30 to 39. So that's what a histogram is good for. It's good for showing numerical data in groups. So a couple of more numerical data displays. Here we have a stem and leaf plot. So this part is called the stem. Here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all our digits down to 9. And then this part is called the leaf. So this is the stem. This is the leaf. That's why it's called a stem and leaf plot. So basically, here's how we read it. And it tells you the key over here. If we have 2 as the stem and 2 as the leaf, that means 22. So if we have 0 as the stem and 7 as the leaf, that would be 7. If we have, let's say, 3 here as the stem and 0 as the leaf, That would be 30. So that's basically how you read a stem and leaf plot. So you can also see a general shape in the data here. So just like a histogram, we've got a band of data points in the 30s, right? So you can see that, we have 30, we have 33, 30 again, 38, 31, and 36. So, it's just a different way of representing the data, just like the histogram would do. It's just a numerical version of a histogram, let's say. Let's talk a minute about line graphs. You're probably most familiar with line graphs, but one thing I want to point out about line graphs is that we want to connect the dots in line graphs. So in order to connect the dots, our data has to be continuous. Now, what do we mean by continuous? So, down here we have dates 1978, 1982. So what's in the middle here? 1979, 1980. So we have some dates that are in between here, even though they're not explicitly written on our graph. So the numbers have to be continuous. Let me give you an example of an inappropriate use of a line graph. Notice that we have categorical data down here. So you can't be halfway in between. This line here would represent something in between Idaho and Wyoming. I guess there's maybe there's a border between Indiana and Wyoming, or Idaho and Wyoming, sorry. But it doesn't really make sense in terms of our data. The only reason, so we would not connect these points, we would just represent them as individual points and not connect them in a line graph if we were talking about categorical data. And that brings me to our last example, which is a scatter plot. In a scatter plot, we do just have individual points that we're recording. And here we're looking at math standardized test grades for 8th graders in 2015. And so we're looking at individual points, but what scatter plots help us to see are trends. So we see kind of a linear trend here. And different kinds of scatter plots, we might see, a trend like this or something like that. Or we might see a group of data down here and then like random data up here. That would tell us something very different. So in our scatter plots, one thing that makes a scatter plot different from a line graph is that we're not going to connect the dots. But we can still see some things about our data and make some predictions and see some trends or patterns in our data.